Thank you. Okay, so like I said, we're going to be working with a b to the x. And like I was saying, if we know, like if I'm every year it's doubling, you know what? Like 5 years is 2 times 2 times 2 times 2 times 2. Why don't you just go 2 to the 5? Like whatever you have times 2 to the 5. Then I go, yeah, okay, that's what you do. Okay? So remember, the efficiency of math makes it confusing. So ab to the x, I can figure out 25 years instead of going times 2 times 2 times 2 times 2 times 2 times 2. Now maybe times 2 times 2 times 2 times 2 would make more sense. Everybody would understand it. Well, every year you're multiplying by 2. And I know at least one of you would come up here and say, you know, times 2 times 2 times 2, 50 times is a lot of work. Like, why can't we just go times 2 to the 50? Right? If you came up with the formula, now you come up with this efficiency that makes sense because of the inefficient way. Math is always, here's the efficient way. And you're like, whoa, 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 like how'd you even get there? And that's my job. Trying to show you how the efficient way was developed. Okay? So, ab to the x, and because you are in the exponents unit, let's do one where we have to find the exponent. Now this is where we have 2012, the university population of a country is 160,000 and was increasing at an annual rate of 4.5%. So it says, in what year, so we're going to do D, in what year would it double? Okay? So what would be my Y? 320,000. So 320,000 would equal my A is 160,000. Now, how much is it changing each year? It's not doubling, so we're not going to multiply by 2. It is increasing by 4.5. So that's where you have your 1 plus 0.045. And you always have to change it to decimal. And that's, like, if you actually just multiplied it by 0.045, that's saying that I'm only keeping 4.5%. But you're actually taking the 1 and a little bit more, so that's why we add. And then this is what we don't know. Now, one thing when you double or whatever like that, you will find that when you first do your very first division, so if I divided both by 160,000, I would have the answer 2, okay, times 1.045 to the n. Now again, we don't have to guess and test. We can find out exactly what n is by log 1.045 of 2 equals n. Now I'm hoping you're getting to the stage now where you're like, well, I would just log that. And that's easy. Instead of 3 weeks ago when you're like, logs, what are logs? Like that even sounds confusing. Okay? Now you should see, oh, that's a pretty efficient little thing. Instead of me guessing and testing or y1, y2. So what do we get as an answer? 15.747 dot dot dot. Now that means I'm going to go and read what I have to round it to. I'm rounding it to the number of years. So what is the number of years for it would take till we say, hey, we're doubled? 16. Now, what if I got an answer of 15.3? Still be 16, wouldn't it? Because I'm not doubling at 15. Okay? So if you have to round to the nearest year in which it does double, and it was 15.3, see, this one's obvious, because even if I didn't know what I was doing, I'd go up to 16. 15.3, I'd have to be like, wait a minute. 15 years, I haven't doubled yet. That's where you put a 16. Okay? It's kind of like, you know, you have to figure out how many cans of paint do you need, and you need 2.3 cans of paint. Well, if you went and bought 2 cans, you would not finish the job. Okay, so when it says round to the nearest can that you'd have to go buy, you would buy 3 cans. And if it was me, I'd buy 4 cans because I'd probably screw up one wall because I'm the worst painter in the entire world. I had a friend over. He's like the painter. He paints everything, never has any problems. I buy the most expensive paint money can buy because everybody says any fool, any idiot could paint if this is the most. So we came and we did all this painting, and it's like this one wall is drawing all weird and it's doing. And he's like, "This has never happened to me before." And I'm like, "Just because I'm in the room. That's why this paint is not working." Okay, so I'd have to. So then we'd have to like sand it down and repaint it. So then we needed more paint. So I always look at the me factor and buy even another can more than that. So anyway, this would be 16 years. Okay? So it would take 16 years for the population to double. Okay, now we're going to talk about where we have decreasing. Now, let's go and do D again. Now, I don't know how many fish I have right now. Who cares? How much do I have next year? I didn't even tell you how many I have, but how much would I have next year? 95% of them, right? So when we're doing decreasing, one of the I guess habits to fall into is just go, hey, multiply by 0.05. See, that's how much would be dying or I would be losing each year. It says, how many do I have? So we will have 95%. So whenever you're losing or decreasing, okay, we would use this formula, n, t, so that's n at a certain time, equals the number right now times 1 minus 0.05 to the t. See, it's decreasing. So I will have 95% of my fish every year. Now, interestingly enough, every single oil company, especially in Alberta, I don't know about the world, but in Alberta definitely, they actually have to hire and pay for, well, they have to have a certain money set aside for environmental. And I know a guy that's what he does. He tests the fish in rivers and lakes in Alberta, and the oil company that is hurting the fish actually has to pay for the guy. Well, actually, they have to give money to the government that pays for the guy to go around telling them that you're losing too many fish, so you have to back off. Okay? And there's many reasons for actually losing fish. It is not just, you would think, putting chemicals in, but if you warm the temperature just a little too much, it changes all the ecosystem. You actually get more algae and less fish and all these things, right? So this is something that is done, right? And you're not allowed to wreck the environment just for your business. So how many years to nearest tenth would it take for the fish population to reduce to half? So I am looking for T. What would be N? N at that time. So N naughts would be what? Like right now, we have 2,500. How much will it be at this time that we don't know? Actually, let's see. We can even put this 0.95 because that's what we equal. But what is N? 1,250, right? Because it says, like, how many years till this thing goes down to half? Now you're like, well, 95% every year. That's pretty good. It's going to take a while, right? Nothing to worry about. Well, you're going to get 1/2 equals 0.95 to the t. And then again, oh, wait, we got to log it again. So that would be log 0.95 to the 1/2. You'll find that when you do get it finally to the point where it is, you're going to find that these are really easy log questions. And if you even look back at any word problem, you can see the algebra is quite simple, but it's getting there. Yes? This is NT. N of T, that's a function. What's the number of fish at that time? Okay, so that's not a variable. What do we get? 13.5134 dot dot dot. So what would be the answer? $13.5 years. Now that actually is kind of scary. Like 13 and a half years for your population to half. That's pretty quick. So when they say we're only decreasing by 5% a year, people would be like, well, that's not so bad. But what if they threw out in 13 years, 13 and a half years, you're going to have half the fish. Then people go, well, that's not good. It's the same thing. Just some people have no idea what math means, so they're like 5%, that's no big deal. But halving in 13 years, it's maybe a little scary. Yep. Yes, technically. Because at 13.5, it really hasn't halved yet. And that's one that you would have a very strong argument for 13.6 years. I would say 13.6 is the more correct answer. Okay? So, but I will tell you the diploma would not be that mean. Yeah, it would not be this mean. No, 13.6, because you could really back that up. I could back up 13.6. So 13.5, are we quite doubled yet? Or halved yet? Not quite. So when did we get to exactly half? If I did the nearest tenth, well, you know, we passed half at 13.6, not at 13.5, right? So technically, I think you would have an argument for that one. And I'll tell you, they field test every question a lot. So what does that mean? There's schools all across Alberta. They write all these questions. They do them all. They look at them. Teachers do them. All the feedback. This one, some would get 13.5. Some would get 13.6. They would go down and they go, you know what? This one's splitting the province too much. Let's really change the numbers or something. So maybe it comes out to be 13.9. And then they'll just say, yeah, that's 14. Or, you know, let's round to the nearest year. And they'd say 14 anyway. Right, so they're very good at making sure that many students have gone through every question before. Now you may think, well, that's kind of an advantage for some students that they get to write those. It is, but you don't get the feedback that year. So that's why I actually haven't done a lot of these. Like I could request for field testing, but they don't tell you your marks until like a year later. If the feedback was in a month, I'd do it in a second. Right? But they can't give out that information because they don't want students to now have those students to have an extra advantage on the upcoming diploma. Okay? So basically you just lose a class. Students write, they're like, was this right? Was this wrong? I'm like, well, I'm not even allowed to discuss the questions with you. Numbers don't come back for a year. So and some people go, no, it's a great advantage because they get to learn how to write those type of questions. Well, I've kind of tried to take care of that in the notes and in the quizzes, so there's no extra advantage, I find. Now, here's one where we have light intensity of a light source is reduced to I after passing through D meters of fog. So D is the depth, right? So basically, I've got a headlight. The thicker the fog is, the less the light goes. It's not rocket science, right? But they actually try to figure it out. So what distance to the nearest tenth or nearest hundredth of a meter will intensity be reduced to 1/4? Now that's not nice and cut and dry. Remember, this is not a variable. E is an actual number, just like pi. And this is where it would be used, okay? So it's used in physics. So what is I and what is I naught? What should be a quarter? I. So it would be 1/4 equals 1 e to the negative 0.1 d. See, I don't know what it is. Like, say that was 100, then that would be 25, right? I would be 25. So then I'd go 25 divided by 100. Oh yeah, that's a quarter. Okay, so no matter, you're going to pick the number that's going out there, and I guarantee it's going to be a quarter of the number in this. So then you'll do that first step, you'll get a quarter anyway. So you actually had to use a quarter to find that number. Now, this is a nice, simple, E is a number, right? So I'm just going to put log E of 1/4 equals negative 0.1 d. Now, if you want to do this all in one step, it would be log E of 1/4 all over negative 0.12. That equals d. Now, why am I showing you this? Because this is maybe where the diploma would stop. So they're not interested at this point if you know how to use your calculator. They're interested, do you even know what it would look like before you put it in your calculator? So I'm always going to show you that step. And you get remember, log E is the same thing as ln, so you could even do this if you wanted to. Right? That's not so hard to put in. Ln 1/4 divided by negative 0.12 is 11.55. Good. Meters. No, let's not get hung up on this one. It gets philosophical at this point. Okay. Next. Half-life, doubling time, that sort of thing. Now, if you've been in chem, you should know this, but every single element on the periodic table has a unique half-life. That means that no two things in the entire world that we know decay at the same rate. So hydrogen would have a different half-life than oxygen. And you would know it's that element by, I don't know what it is. Let's see how long it takes to decay. It took 2.3 hours to go to half. You can look right in the periodic table and you'll know exactly what element it is. Okay? And that's why carbon dating is what's used for when they find bones or they find remains or whatever, because when we decay, any animal decays, it leaves carbon behind. Right? So they can find the decay, and they can tell pretty close how long that thing took to break down. So therefore, they know how old it is, right? How long it's been sitting there, not how old it is, because we don't know if it was 60 when it died or 50. We just know how long it has been deceased. Now, here is the formula for half-life. Now, do you see there's a half there? That's because it's going to half every time, right? It's a half times a half times a half times a half times a half. And then after a while, we're going, why don't we just go 1/2 to the 5th if it's 5 years? Okay? But this is important, this h. Now, this h and this belong together because that h is the half-life time. Time is how long it's been decaying. H is the half-life time. They're very different. How long has that been sitting there is very different than what is the half-life of it. If the half-life is 3 years and it's been sitting there for 10 years, my 3 is the H, the T is the 10 years. It's been sitting there for 10 years. H is how long it takes to go to half. Okay? So don't mix those up. They're very, very different. Figure out how to Mr. Ashton is very, very good at his math. For anyone that has him for calculus, they're very fortunate because he is definitely the best sub in Edmonton Public. He was actually my department head like 15 years ago. But I got him on a tough problem. See if you can get it. Okay, now this would be the doubling time. Okay, formula. Now you can see where the 2 is, because it's doubling every time, times 2, times 2, times 2, times 2, times 2, okay? And this is the doubling time. Now, so to be very general at this point, this is going to be the formula that we will use right here. The amount that is left equals the amount we started with times C. C is the constant. It is 2 for doubling, 3 for tripling, half for half-life, okay? So that's C. P is the period for doubling, tripling. So these two are a team. I always circle them to make sure, say the half-life is 2 years, a half and a 2. If the tripling time is 8 years, 3 and 8. 3 for tripling, 8 for the 8 years, okay? If you look on your formula sheet, it does have the decay growth formula, but it uses AB instead of A naught and C. Okay? But the T over P, because that's period, I think it uses the, okay, but just know what's on there, okay? So you get a patient feeling ill and has a sample of throat bacteria contained 387 cells. 24 hours later, it was recounted and was found to be 812 cells. Now, there's very different types of bacteria on the planet. I think you can imagine that. But they don't actually look at it under the microscope and go, oh, that one has the little hairs and this little part of it here. So that's the type A47 bacteria. No, they know every bacteria from its half-life. They put it in a little petri dish. They see how long it takes to half. Look that up in the book, and that is the CA42 bacteria. Okay, so most viruses, cancers, bacteria are identified by their half-life, not by how they look, because they all look the same under the microscope. Like viruses are, you know, they look very much the same, but they are different. There are different types of viruses. I think we can assume that, right? There's the colds virus, there's the AIDS virus, there's different viruses, right? So let's find out what this one is by looking at its half-life. So we have this formula, A equals A naught times C times T over P. Okay, now what can we fill in? What's A? No. Yes. 8,012. What do we start with? 387. So would this be a decay or growth function? Growth, right? So this is important. If this is a fraction, we must be going down. If it's a number greater than 1, we must be going up. Okay, what number would be in there? Just find the doubling period, the 2. Now, what is my unknown? T. T over 24. Because it does give, in 24 hours it did double. So we can also tell by this how long, well, yeah, we want to tell how long has it been in the Petri dish. Oh no, this is not right. Is it? Yeah, we know how long it's been in the Petri dish. We don't know the doubling period. Does that make sense? It didn't say it took 24 hours to double. It just said it's been sitting there for 24 hours. If I go find the doubling time, So we can use a P there, we can use a D. If I find that, I can look it up in the book or obviously in a computer now. That is the type of bacteria I'm dealing with. And then you have to give them a call. Your doctor wants to know what type of bacteria you have. Okay, so anyway, the first thing we're going to do is we're going to divide 8,012 by 387. Now that doesn't work out nice, so I have to leave it as that, okay? That is a reduced fraction, equals 2 to the 24 over P. Now, what I want to do is I want to get that P down out of that exponent, so I can log it. So that's log 2 of 8,012 over 387. Now again, I'm getting it set up for maybe the diploma just wants to know what would it look like before I put it in my calculator. Now, this is all over 1, right? So these two can trade, right? So I can get P all by itself. So P would equal 24 over log 2 of 8,012 over 387. Now I'm always going to take the time with you to get it to P equals in case you ever get asked that in the diploma. Cody, I need you to watch it up here, okay? Now, put it in. So you're going to go 24 divided by, and you're going to want to open a bracket right here. If you don't, you'll get it wrong. Mel, what'd you get? You didn't do it. That's not good. Spencer, what'd you get? 5 point. Say it again. Okay, so what would it be to the nearest tenth? Okay, so you just have to go 24 divided by and then hit bracket. Log 8,000. Now log, the bracket opens, 8,012 divided by 387, close the bracket, divided by log 2. Okay? Okay, example 5. Now, none of you were alive for this Chernobyl meltdown, but it's a pretty big impact in the world because nuclear reactors are touted as very clean energy. But in Japan, when they had that earthquake last year, the big thing was they got a lot of nuclear reactors, and if those crumble, obviously now you've got all this stuff in the atmosphere. Well, this was a big deal because this is the first meltdown, and this happened in Russia. And I mean, at this time, Russia had absolutely no money. So you think they maintained their stuff? No. Okay. And because of poor maintenance, Chernobyl, it blew up, right? Which is the world's biggest fear, because, you know, their air is our air, and all comes around over here, right? Now, obviously, it hit this area, and the whole town was evacuated, and the whole thing. And if you see, anyone seen the movie Chernobyl Diaries? Did you? It's good. No, probably not that good by the sounds of it. Okay, but anyway, there's a lot of, a lot of cancer. A lot of birth defects came in the Chernobyl area after this, okay? So anytime anyone says, I want to put a nuclear reactor in your backyard, let's go for it, now you understand why everybody goes nuts, right? Because of this. Everybody remembers this that was there at that time. Now, what we're looking for is, it happened, we know the half-life of radioactive iodine is 8.1 years, or days. Determine the number of days that for it the level of radiation to reduce to 2%. Okay, maybe the experts say when it's below 2%, it's not harmful to humans, so we're not going back until that time, right? So they have air testers, they test it out, and they know how. But the thing is, they would like to know, just sit down on a piece of paper and figure it out. You don't have to go every day and check it, and then come back and check it, and come back and check it, if you know how many days would be happening just through the math, right? So if you have A equals AO times C to the T over P. Okay, what can I fill in? Okay, C is what? Half. What else? P is 8.1. We're looking for T, right? Now, how much do we start with? Yeah? No, because they asked us for the number of days, so that works out good. You got to keep that the same. Yeah. Very good question. Yep. That's what I would do. Or if you wanted, you could put 102. Yep.
So, one half there, is that because it's decay?
No, because of this thing. Half-life is always a half. Okay? That's the constant. So now you just have 0.02 equals 1 half T over 8.1. So now you can do your log, right? I'm hoping that at this point you're going, yeah, it's no big deal. I'll just do a log. Okay? Now, maybe, and you see how the 8.1 can just come up here? Times it by 8.1. So that's log 1 half to the 0.02. So I know a couple weeks ago logs looked pretty weird and kind of confusing, and now it should be just like, okay, that's how I can get that exponent down. Okay, so everyone get it in. Again, I've shown you what it would look like right before a calculation. What are we getting? What are we getting? How many days till we should return? 10.57. No. Yeah, 45.715. Now, would you go back at 45 days? Even if it was 45.3 and I had to go back on a certain day, I would pick 46 days because it says to the number of days. So that is the earliest people should go back, right? Okay, next one, I just quickly want to set up the formula. Radioactive isotope has a half-life of 7 years. That's these two things. Everyone see that? Just gave me the C and the P. Half-life of 7 years. And that's how I write it, right? Half-life of 7 years. So I read it, I write it. C is the half. Determine how much of the isotope must be present to decay to 60 grams in 14 years. What am I looking for? A naught. Like right now, how much do I have? So 60 equals A naught times 1/2. This is 7, and this is going to be 14. So this one is so easy, you don't even need logs. Just go 1/2 to the 2, or 60 divided by 1/2 to the 2. Right? And make sure you do 1/2 in brackets, or else you'll just do the... So you will get 240 grams, right? So 1, 2, 6A, 8, 9, 11 to 15.